Okay, so for this question, the first thing you want to do is distribute the parentheses. That is always your first step. And so what you need to remember with distributing the parentheses is that it's 2 times x to the 10th. So the 2 will get the raised to the 5th power, and then the x to the 10 raised to the 5th. Remember, if you have an exponent to an exponent, you are going to go down a level in PIMDES and multiply those exponents together. So that will give you x to the 50th. And then in the denominator, you will also need to distribute this 5 exponent to the 5 in the denominator because it's 5 times y to the 4th. So it'll be 5 to the 5th and then y, and then we have our y to the 4th raised to the 5th. So we multiply those exponents together to get y to the 20th. So again, we're distributing our parentheses, and when we have an exponent to an exponent, we're multiplying those exponents together. The same thing is going to happen over here. However, your exponent is 1, so there's nothing to distribute, so you can just drop those parentheses. So you'll have 5 to the 3rd, y to the 9th, over x2 to the 4th. And right here, you can always move your negative exponents at any time, but I like to move my negative exponents as soon as I possibly can. So when I'm working through this and I see this negative exponent, I wouldn't delay that. I would immediately move that up into the numerator. So that would become x to the positive 9. Now, there's a lot going on with this problem. First of all, you have multiplication of two fractions. So there's some basic knowledge here of with fractions, you multiply straight across. So you're going to multiply across, and this is going to become one big fraction. Now, when you do this, I personally try to line things up. So I'm going to start with my 2 to the 5th, and then I have my x to the 50th. And if I scan through this, I also have an x to the 9th power. So I'm going to line those guys up. And then I have the 5 to the 3rd, and then the y to the 9th. And then in the denominator, I have this 5 to the 5th. Now you'll notice that in this numerator, I also have a 5 to the 5th power. So sometimes I'll try to put that right below the other 5 base so that I can see it visually. You don't have to do it, but it kind of helps to visually line things up in that way. So again, I notice I have a 5 to the 3rd. I also have a 5 to the 5th. So I put those right below, or right stacked on top of each other. Then this y to the 20th, I noticed that in the numerator I have a y base over here, so I'll put that right below it. And then the 2 to the 4th over here will go stacked right below the 2 to the 5th power to kind of help me with my exponent properties. So then I can subtract exponents. So when you are dividing exponential terms, you are going to subtract the exponents, and just remember that the bigger exponent is where you end up. So if you bigger exponent is where you end. It's one way of thinking about it. So here I have a 2 to the 5th and a 2 to the 4th. They both have a base of 2, so I can subtract those exponents, 5 minus 4, and the bigger exponent is where I'll end. So that'll be a 2 to the 1st power. Now, you'll also notice that in the numerator, I have an x to the 50th times x to the 9th. That is a multiplication of exponential terms. So I'm going to go down a level and add the exponents together. So that's going to be 50 plus 9 to get x to the 59. And then here with my 5 to the 3rd, 5 to the 5th power, looking at those two exponential terms, I can subtract their exponents, and the bigger exponent is where I'll end. So that will be in the denominator of 5 squared. And then my y to the 9th and my y to the 20th, those guys have the same base, so I can subtract their exponents. So 9 minus 20 will give us a y to the 11th. And notice that I'll put the y to the 11th in the denominator because the bigger exponent is in the denominator. Now, let me write this over here. I'm looking at 2 to the 1st, so just 2, x to the 59th over 5 squared, and I can calculate that 5 squared. So using my calculator if needed, I will hit 5 and then 5 and then the square button, the x squared button, to get 25. So the 25 is coming from that 5 squared there. So 25 and then y to the 11th. Now notice I cannot do any additional subtraction of exponents because these have different bases. So that's as far as I can go for this problem.